Hi friends, in this session we are going to discuss about the tricks regarding pulleys. We are going to speak about the shortcut tricks that we could use to solve pulleys. We'll solve it from simple to complex. Let's have a diagram over here. It's not a pulley, it's a string which is having a mass attached over here. Then let's analyze the force acting over it. That is, if a mass is attached over here, there will be a force acting vertically downwards and that force will be equal to mg. The string is an inextinguishable string, that is, its length is not changing. If its length is not changing, it will be at rest itself. But if we are analyzing the string, at this point there will be a tension acting on the string. The string which is connected to this mass will experience a tension in this direction, and if we are analyzing the portion of string which is connected to the ceiling, it will experience a tension T in this direction. Therefore, I'm speaking about tension. If a string is laid between two fixed points, then there will be a tension. The tension will be over here, the direction of tension is like this, over here the direction of tension is like this. Most of the case we will analyze this tension only, but you have to understand this tension like this also. Okay, then if I have to formulate an equation over here, the substance M is at rest. If it's at rest means the net upward force and net downward force should be equal. Therefore we could formulate an equation T is equal to mg, and I could write like this also, that is, the net force acting on this is 0 is equal to T minus mg. It is due to T tension is in this direction, mg is in the opposite direction. Therefore 0 is equal to T minus mg is good, or you could directly write T is equal to mg. Okay. Then coming to this diagram, we are having a pulley. This is a pulley, it's a frictionless pulley, and it's fixed at one point. This pulley is fixed at one point, and there's two mass attached. You can see it is 2 kilogram and 2 kilogram. If it's 2 kilogram and 2 kilogram, it won't move. It will be at rest. But why I am drawing this diagram over here is to explain what is happening in the case of tension in the case of a pulley. Therefore, analyzing this force, this 2 kilogram mass will experience a force 2g. Let me write 20 Newton. We are taking g as 10, 20 Newton. Then there will be a tension on the string in this direction. Let me write it as T. The peculiarity of pulley is pulley will change the direction of force. It will not decrease or increase the force. It will simply change the direction of force. And if you are analyzing this string, this is a single string. Therefore, the tension that is over here, it should be exactly equal to the tension at this particular point. Therefore, if it is a single string going through a pulley, the tension T will be same as that of the tension T over here. Tension will be same. And if you are analyzing, there will be a force acting downwards, and over here there will be a tension acting downwards, but we are not referring that. Therefore, let's look over here, this 2 kilogram mass, it will have a gravitational force of 2g, that is, let me write 20 Newton. Therefore, if you are formulating the free body diagram from here, you could write T is equal to 20 Newton. From this is also T is equal to 20 Newton. Is it clear? Then these are some basics. Then let's move on to the next thing, that is, can you see a diagram? This diagram like this, and in this diagram we are having a pulley, frictionless pulley. There is two masses, 3 kilogram and 2 kilogram attached over here. Will it be at rest? No. This is 3 kilogram and this is 2 kilogram, means this 3 kilogram will move down and the 2 kilogram will move up. Okay. Then in this case, our task is to find out the acceleration and tension. We have to find out the acceleration and tension in this case. Then for that, let me say some basics. What's the expression for force? The basic expression for force is F is equal to ma. Then what is A? A is equal to F by M. This formula, simple formula, will help us in solving many complicated questions regarding pulley. I'll say how. We have to remember it like this. The net acceleration of the system will be the total external force divided by total mass. Let me repeat. The net acceleration is the total external force divided by total mass. I'll say how to use it with the example of this problem. That is, what is the total mass in this case? It is 3 kilogram plus 2 kilogram. It is 3 plus 2, it is 5. Is it clear? Total mass. Then the total external force. In this case, the total external force, that is, you analyze this 3 kilogram mass, it will experience a force downwards, and that will be 3g. Let me write 30 Newton. Clear? And this 2 kilogram mass, it will experience a force of 2g, that is 20 Newton. And will this system be at rest? No. 3 kilogram is greater than 2 kilogram. Therefore, there will be an acceleration in this direction. The 3 kilogram will move downward with an acceleration. As a result, this 2 kilogram will move up with an acceleration a. Then the net external force. Should I take 30 plus 20? There's a rule for that. That is, if the force is in the direction of acceleration, we have to take it as positive. If the force is in the opposite direction of acceleration, then that force has to be negative. That is, the net external force in this situation is this 30 Newton is in the direction of acceleration, therefore plus 30. This 20 Newton, it is in the opposite direction of acceleration, therefore minus 20, that is equal to 10. The net external force is 10, the total mass is 5. Therefore, by using this expression, acceleration is equal to 10 by total external force is 10 divided by total mass 5, that is 2 meter per second square. Clear? You could go through the standard formula and you could substitute the values in the standard formula, you will get that same answer. Okay, then the next thing is we have to find out the tension on the string. For finding out the tension on the string, let's mark this is our T. The tension that is acting over this 3 kilogram string will be T in this direction. And if we are analyzing the free body diagram of this, let me solve it over here. The free body diagram. What is the net external force over this 3 kilogram mass? This 3 kilogram mass is moving downward with an acceleration A. Therefore, the net external force is downwards and it will be 3A. Net force is 3A. It is due to the result of this T tension and 30 Newton. T tension is pulling it upwards, 30 Newton is pulling it downwards. Which is the direction in which it is moving? It is moving downwards. Therefore, T or 30 Newton, which is greater? 30 Newton is greater. Therefore, we will have to write 30 minus T, that is 3A is equal to 30 minus T. How? The net force is mass into acceleration 3A. It will be equal to greater force minus lesser force. Okay. Then let's substitute it. Or in substituting the values, we know acceleration is 2 meter per second. Therefore, 3 into 2 is equal to 30 minus T. Minus T is taken to the side. T is equal to 30 minus 3 2s are 6. Therefore, 30 minus 6, that is 24 Newton. This is our tension. The tension on the string is 24 Newton. Let's analyze with some other method also. In order to understand, we have obtained the answer. We'll try to get the answer from this diagram. That is, if there is a tension T over here, since it is a single string, there will be a tension T in this direction also. And if you are formulating the free body diagram in this case, the net force is 2 kilogram mass moving upwards. Therefore, net force is 2A is equal to, what's the direction of tension? Upwards. Direction of gravitation force is 20 Newton downwards, which is greater. Tension is greater. Why? Since the substance is moving upwards. Therefore, it is T minus 20. Substituting for A, 2 into 2 is equal to T minus 20. We'll get T is equal to minus 20 to the side. 20 plus 4, T is equal to 24. Same answer. No need of doing this, but I've done this in order to make you understand how this is happening. Okay, 24 Newton. Hope you are clear with this derivation. Now, let's try another question. This is our question. We are having a frictionless pulley over which 4 kg, 6 kg mass is attached over one side, 5 kg attached over the other side. Our question is to find out the acceleration, tension of the acceleration and tension of the string. Okay, over here, initially we will write the formula. Acceleration is equal to the total external force divided by total mass. Then, in this case, what is the total mass? Total mass is 4 plus 6 plus 5, that is equal to 4 plus 6 plus 5, that is equal to 15 kilogram. Clear? 15 kilogram. Then we have to find out the total external force. Tension. Tension, is it an external force or internal force? Tension is actually an internal force. That's why we are not taking the tension, or we are not drawing the diagrammatic representation of tension initially. We have to find out the net external force. In order to find out the net external force, let's start from here. This 5 kg mass will experience a downward gravitational force of 5g. Let me write 50 Newton. This 6 kg mass will experience a downward force in this direction. Let me write 60. 60 is 60 Newton. This 4 kg mass will experience a downward force of 4g. Let me write 40 Newton. Clear? Then, what's the direction of acceleration in this case? Since this side is having a total mass of 10 and this side is already having a total mass of 5, obviously the substance will accelerate in this direction. As a result, this 5 kg mass will move upward. Clear? Then, over here, the forces which are in the direction of acceleration is taken as positive, the other force is taken as negative. Therefore, this 60 and 40 is positive. 40 plus 60, but this 50 Newton is negative. The force is in this direction, acceleration is in the opposite direction, therefore minus 50. The answer is 40 plus 60 is 100, 100 minus 50, 50. The external force is 50 Newton. Therefore, our acceleration, it will be A equal to total external force divided by total mass. If you are solving this, we will get 3 by what? 10. 3 by 10. And I'll write that much meter per second square. We'll take it like that itself. Then, now let's find out the tension. Will the tension over here, here and here be same? No. Which is a single string. This is a single string, this is another string. What I've said is, for a single string, the tension will be same. Therefore, the tension over here, it will be, let's call it as T1. That should be exactly equal to the tension over here, that is T1 itself. Okay, then let's find out the tension by using the free body diagram in this case. Now, this 5 kilogram mass is moving upward with an acceleration. Therefore, what we could say is the net force acting is 5A, and it is due to the result of these two forces. T1 is upwards, 50 is downwards, which is greater. T1 is greater while acceleration is upwards. Therefore, it should be T1 minus 50. Substitute for A, 5 into 10 by 3 is equal to T1 minus 50, minus 50 to the other side. T1 is equal to 50 by 3 plus 50. And on solving it, we'll get 50 plus 150 by 3, that is equal to, it's 200 by 3. The T1 tension is 200 by 3. And next is, we have to determine the tension on this rope. Will it be equal? No, because this rope and this rope are two different ropes. Therefore, let me write or draw the direction of tension. It's not same, therefore I'm writing it as T2. And if you are analyzing the free body diagram in this case, if you are analyzing the free body diagram, the 6 kilogram mass is moving downward with an acceleration. The net force is 6A is equal to, should I write T2 minus 60 or 60 minus T2? Which is greater? 60 Newton should be greater because acceleration is downwards. Therefore, 60 minus T2. Therefore, 6 into A is 10 by 3 is equal to 60 minus T2. T2 is equal to 60 minus 60 by 3, that is 60 by 3 is therefore 40 Newton. T2 is equal to 40 Newton.